welcome to this quick webinar on the data-first front-end revolution with Kia. So I'm going to be your host, Marius. Feel free to interrupt me every now and then, say hi, like some of you are doing, ask your questions, whatnot. But yeah, let's go on. So what will we be talking about today? So first up, I'm going to be presenting to you my framework called Kia, which is for managing state with React. I'm going to do some live coding to build a few sample applications with Kia. I'm going to spend a few moments describing the approach behind Kia, which is what I call data first. We're going to do a bit more coding, questions, answers, and perhaps even more coding. We'll see. So yeah, like I said, feel free to interrupt me at any moment, ask your questions. If they're relevant, I will answer them directly. If not, perhaps I will wait until the end, but yeah. So what is Kia? First up, it is a parrot from New Zealand. It's this guy here. He or she is a alpine parrot in the South Island of New Zealand. It's a very cheeky bird. Look up videos of this guy. They're pretty interesting. But in addition to that, Kia, you do not see any screen. Oh, that is, oh, I'm terribly sorry for that. Let's go again. Yeah, perfect. Sorry for that. So I'm going to show you those beautiful pictures I had here. So yeah, as I said, what we're going to cover. First, what is Kia? Do some live coding. I'm going to explain the data-first approach to front-end coding, which is kind of the approach that's powering Kia. I'm going to code a bit more, do some question and answer, and even more coding. So what is Kia? First up, yeah, as I said, it's a parrot from New Zealand. It's one of the most intelligent birds in the world. And if you just look at some tests people do on these parrots, it's pretty amazing to see what they can actually accomplish. They're like at the intelligence of a 4-year-old human child or so. So, but in addition to being an awesome parrot, Kia is also a state management library for React. And why is it called Kia? Because, well, just before coding it, I was on holiday in New Zealand, and the name was available. So, simple reasons. And yeah, the beginning of the framework is that it started in 2015 as an abstraction over Redux, which is what I was asked to code a project with for a consultancy. And while doing it, I realized that Redux is very boilerplatey, or at least in 2015 it was. Now it's a bit better, or a lot better, but that was the state then. And so everybody started writing their own wrappers around Redux, including me, and mine grew into a project that we then used with the consultancy, later in 2 other startups. And yeah, now I'm also using it for work, and it has evolved since then. It's used by a bunch of big projects. I use it myself daily in my work in PostHog, which is something you should check out if you have a website or an app and you need some analytics. It's something pretty awesome. But yeah, so some of the interesting feedback I've gotten for Kia is that first, it scales very well. That means that it's easy to get started, but as your app grows, it still remains maintainable, which is a very interesting side effect. And yeah, I've also tried to design it in a way that it sparks joy. So whatever that means is up to you to decide. But enough about that. Let's just get straight into it and start coding. So I'm going to just create a small template application for Kia using the create React app template that we have for Kia and TypeScript. I'm just going to call it Kia Webcast. It's going to install for a few moments, and once it's done, I'm going to just open the same project in VS Code and just get into it. Actually, I think I can already open the project, so I'm going to just drag it here. Yeah, so here we are. I'm going to zoom in a bit. Hopefully it's big enough for everyone to see. So, still installing. I'm going to just open the terminal here. And once it's done, I'm going to type yarn start, which will do 2 things. First, it's going to start the, actually I'm just going to show. Show, don't tell us, they told me a long time ago. So what yarn start is going to do here, it's going to actually start two things at the same time. Start create React app and start typegen. And typegen is an interesting project that you will see live very soon, which is the way we actually do TypeScript in Kia. And I will get to it as soon as we see some code. So let's go. We're starting typegen, starting the project. Eventually, and there we go. So we have something here, and it's working, and that's awesome. But now we're gonna actually make it into a interesting application. So the first thing I want to do is just make a new folder here called counter. So we're going to be making a pretty contrived, simple counter app that will have a bunch of cool features, not just adding and subtracting. And I will use it to demonstrate a few different features of Kia. And then we're going to refactor it a bit, and I will try to use that to demonstrate the data-first approach of Kia. So these I don't care about. Yeah, terminal. So the first thing we do is this is kind of the smallest Kia application I can. I'm gonna hit save, and immediately you should notice that something interesting happened here, which is Kia typegen. And if you see the syntax of Kia, you will realize that it's actually pretty complicated to type effectively. And to get around that, we have a feature called typegen, which is an application that's running using the TypeScript compiler. It will come in here, look at your code, and automatically create this file with this type that contains everything that this Kia logic contains. Right now it's pretty small, but it will get bigger. So logic, what's logic? In Kia, the way we manage state is that we create these kind of logic containers. And logic is kind of a different name for state, but state to me is just basically variables. Logic, however, also contains the logic to interact with those variables, to change them, to alter them, to so on. So yeah, and we're also going to create a small function. So this is a React component. Let's just return nothing useful now. Let's export this as well. So, and just to get everything wired up, we're just going to remove this part and put the counter here. So yeah, we still keep the spinning bird because I honestly believe it's just too awesome to remove. And we'll just add the counter below. So, simple example. What do we need for a counter? What should a counter do? Well, increment and decrement numbers is kind of the basic thing, and that's what we're going to build first. So, yeah, thank you. That's correct. So in Kia, everything starts with an action. That's something that you read in the documentation. And the action in Kia is basically a Redux action. There is not really a lot of difference other than just some automatic binding of dispatch and so on. So we're just going to have two actions for now, increment and increment. So, two spaces there. And yeah, I mean, obviously nothing changed here yet. So actions are great, but on their own they cannot do nothing. They just signal intent. They say that something should happen, and now it's up to us to write something that reacts to an action. And we're gonna use reducers for this now. And we're gonna just make one reducer called counter, give it a default of 0, and tell it that in case of let me save. In case of an increment, in case of a decrement action, the counter is just gonna go down by 1. All in all, really simple. You might be wondering, why am I wasting your time with such a small, pointless plus-minus thing? But we're gonna get to something really cool soon, so just bear with me there. Now, how do you get this information in React? Well, Kia has a few functions and a few hooks. And one of them is called useActions. We just pass in our counter logic, and the other one is called useValues. And so let's have a look at this type now that TypeGen has generated. As we can see now, it has 2 actions, increment, decrement, and the reducer that at the end of the day returns a number. And this is what we can directly access here now. So let's take these 2. And there's a value, let's take counter. So the way you structure your logic with this input is that you have a bunch of actions, and then you have all sorts of other stuff, including reducers that do something with those actions. At the end of the day, every reducer, every selector, and a bunch of other stuff ends up as a value, which you can also see here, just values. So this logic has just one value, counter. And yeah, let's just plug them in. There. And here we go. Amazing, huh? This is, I'm sure, what you all came to see. Some guy writing a number under a spinning bird that you can plus and minus. Is that right? That's why we're here? Great. Then let's go on. The counter actually, let's actually call this counter something else. Let's call it startup value. So now we're actually going into something exciting. So this is the value of your startup and whatever it is, and you can make it go up. Isn't that great? Or make it go down. But because we are participating in a VC Ponzi scheme, we have to actually just double our value. So for that, I'm gonna use a feature called a selector, which is, basically computed properties is maybe another way to describe it. And the selector called double counter. The way you define a selector, so yeah, this is all just syntax. I'm just gonna write this out. So the way you define a selector is by giving it a bunch of inputs, which is the first array, and then it will calculate the output. So in this case, just take the counter. And wait for TypeGen to update. And as you can see, all the types propagate automatically throughout this logic, just thanks to TypeGen. And let's have a double counter here. money in front. So there we go. Isn't this exciting? I'm sure you all came here to see some guy make a counter that, in addition to adding and subtracting, can also multiply by 2. So isn't that amazing? All right, now let's get to the more exciting stuff. So this was kind of the first phase. Now let's go to phase 2, which is that we're gonna actually have some side effects and some interesting things happen. And as I said, in Kia, everything starts with an action. So a reducer listens to an action. Selector takes a reducer. So okay, selector doesn't start with an action, but all data changes and all side effects and everything else start with an action. So let's just add something. We were contacted. So we have this beautiful startup value counter, and we were contacted by the CEO who wants us to drive engagement and show a message to the users whenever they increase the startup value. So let's do that. So basically what we want is that when you increase, we're going to tell you that you're doing a good job. Clear? So how do we do that? Well, first, let's just organize our code a bit better and have a new file here called counter logic. It's always good to kind of split these things up. So save, import Kia, save, and this one. Let's import the file, and we don't need this. So this just makes it a little bit easier to write and reason with. And I will explain a bit more about this approach later when we talk about data first. All right, our goal is to show a message that says that you're doing a good job whenever you increase your startup's value. And that's a laudable goal, so let's just go for it. For that, what we do, message. Let's have it as a string initially. Right, and so here you can see one of the interesting things of Kia is that you, I'm sure some of you might have been wondering when we started that why did it take so many lines and so much code to just make a simple counter? I mean, you can just always go const, and that's it. I mean, one line, boom, done, get your bonus. But the magic here is that if you actually write a bit more code in the beginning, you're gonna have a better time after all. Because like I said many times now, everything starts with an action. And if you just clearly define your actions in the beginning, you're just gonna, everything in your application is just gonna go through one specific path. And everything is gonna react into that path. And so your entire data flow is very controlled and self-contained. And that's a good thing. Anyway, so we added a message. What we're gonna do here is just, it's not there, error. So it's a value, right? So now what happens? I increment, and it's a good job, but I'm now decrementing, and it's still a good job. That's not really a good job, so something is wrong. What should we do to fix this? Any ideas? Anyone? Anything blindingly obvious that I should do to remove this message here? So go browser load. So increment, good job. Decrement, not a good job. So that's nice. But there's a new feature that marketing is telling you, which is that people get discouraged when they see that they're doing a good job too easily. So somebody comes here to increase your startup's value, gives you another $1, and I mean, good job, done. So why bother? $1 is enough, or 2 if you multiply. So marketing came up with another demand, which is that we want to see the message only about 1 second after the user has clicked increment. How do we do that? If you are using React and you are not in the data first mindset, you're gonna go with a useEffect and gonna do some whatever other options. But that's not really the way we do things here. So what we're actually gonna do is we're gonna use another feature of Kia called listeners. And yeah, so we are going to actually change this now. We're going to make a new action called set message. And other than these two actions that got no parameters or no arguments, so we could just use them here like this. In some frameworks, you need to do this, but not in Kia. You can just go for it. Let's take a message. And the way actions work in Kia is that you have a function set message, takes an argument, and then it returns a payload. And this is the part that some people find annoying with Kia, yet I find it extremely empowering, because every action, however you want to give it an arguments, returns one simple JavaScript object. So if we would then in the backend, all of this hello is translated into, and that provides us with a bunch of nice features that you're gonna see in a moment. And yeah, let's get rid of this. Set add a listener for increment. And so what is a listener? Basically here you can write any kind of code. A reducer is a, so I'm assuming all of you know Redux or have some idea of the functional principles behind Redux. And a reducer is a pure function. So the only thing it does is it takes this existing state and returns a new state. But a listener is something where you can just do anything. You can write API requests and so on. So what we're gonna just do here, we want to call so we now have a reducer message that whenever a function, action set message is dispatched, it will be dispatched. This is the state, that's the existing state. We have an empty string here, but since we do nothing with existing state here, we're just going to discard it. And then you get the payload, which is this object here. You could do this and take the message like this, but there is real value in making sure that every payload is an object with values, and it's just consistency and just makes your life easier. So we're going to do that. But where do we get it here? That's a good question. So Kia has this cool feature that every object here, and this is why it's really hard to type it, every object that you have here has two options. It can take just some kind of a object, or it can take a function that returns an object. And if you take a function that returns an object, what is this here? This is the logic itself. So this counter logic is basically here. You're just getting it inline. So you can destructure it, get actions, set message. Good job. So let's see. Will this work now? We have refactored it from using a reducer to using an action because we need the timing logic. So let's also take the Redux DevTools. So you can see the increment, and right after the increment, we have a set message, which updates the message. And increment updated the counter. And this set message, nothing changed here. So that's great. But now we want to do the original requirement that it should show up in half a second. So for that, Kia has a very nifty feature called the breakpoint, and I'm gonna get into it more. Basically, right now you can just use it as a timer. Yeah, Kia is a layer over Redux, but a bit more, not just a simple wrapper. So now you can see, click increment. It takes a few seconds for a good job. So now we have another requirement is that we want to clear the message after a while. So let's just only show it for a second. And let's see what happened. So we can now keep clicking it. And at the end, it's just going to say good job. So this is the magic of breakpoints. What does this here do is that in case increment is called again while we are awaiting here, none of this code gets executed. It's just going to throw here. So we can actually see this. So a lot of breakpoints are just going to be firing here. And what this does is that actually we can click as many times as we want to really increase our startup's value. And we're not going to see the message, only right after. So a few more things we can do here. This looks pretty ugly, so I'm just going to make a new action called clear message. And it's a bit nicer here. And I'll remove this code, make it cleaner. The other thing we want to do is to say that you're going the wrong way if you decrease startup value. And one more thing is I would actually like the message not to be an empty string, but a null if it's nothing. So this is going to cause some errors with pipegen now because the message is null, which is not true. It's actually a string. So the way around it is to specify this default value is actually null or string. And now we clearly see that the message can be null or string. So let's see what happens. Failed to compile. Huh. What did we do here? String is not assignable. That's an interesting situation. All right, I'm just going to ignore this for now. Let's, because we're running out of time. Give that an empty string for the moment. All right, so, but the big problem that we now have is that if you increment this, so let's decrement and increment quickly, and we still see that this message just keeps going in a weird way. We would like to not have anything until we increment, so or until the time passes. So the way we refactor that is that we just make a new action called setMessageText. Actually, do this. And just with a few refactors, assuming everything works, we can click on both of these things as much as we want, but only when we stop clicking for half a second, we will see the message, and only then for 1 second. So another thing we could do is just that so that the first time, so if there's a message there and we're going to start incrementing, decrementing, it just goes away. So yeah, this is kind of the fun stuff you can do with Kia. Let's go into the presentation now. So what was I doing there? What's happening here? So the way, interesting. The way I would like to describe this is that Kia is what I would call a data layer. And I know that basically any other state management framework is also a data layer in some way. But what makes Kia unique about it is that it tries to really be a self-contained data layer that you can even use without React if you really want to. And when I got started with React many years ago, then I also started looking at this language called Clojure. And I started looking at the different ways to do frontend in Clojure. And there I realized that every Clojure frontend framework goes through 3 steps always. You always have the input layer, which is whatever data you get from the API, from whatever search field input, the URL of the browser, etc. Then you have a data layer, which takes the input layer and converts it into an intermediary state. And only finally you have the view layer that just displays this information. The difference here is that I've heard a lot of people try to just use the React context and kind of store your data inside the React component. But I think that's a really bad idea because that's really messing up your view and data layer separation. And so my strong suggestion, based on the experience looking at all sorts of other frameworks that really know how to manage data, is that you should probably stop thinking in this way, where your entire front end means that you have React, in which you build your entire application, and then you just add a state management library on top of that. Instead, if you really want to have a strong and stable application, then you should probably architect your application in a different way, which means that you first have a data layer in which you just do everything that you need, that your application needs. And only then do you give this data to your view layer, which is React. So that's kind of what we were doing here all this time, is that, why do things keep disappearing? This counter logic is now part of the data layer. How is this happening? I'm not pressing anything, but it just keeps going. And as you saw, we had a bunch of requirements here with the message. We need to show it when this happens, and then we need to show it when that happens, and then we need to hide it, and then we need to not show it in this case. It would have been really annoying and cumbersome to do it inside React directly. You would have a bunch of different set timeouts, useEffects, etc. But if you just split your data and template or view layers, and you just relegate React to what it does best, which is just really insanely and amazingly diff and render DOM nodes, you're probably gonna end up with a stronger and stabler front end. And there is a quote by some guy called Rob Pike, who maybe some of you know, he has done a few things, like invented the Go language and a bunch of other things before when he worked in Bell Labs. And he has one rule, which is data dominates. If you've chosen the right data structures and organized things well, the algorithms will almost always be self-evident. Data structures, not algorithms, are central to programming. And I would expand on this, like in the modern front-end world, data, not DOM nodes, not templates, is the central of programming. So what does this allow us to do? Well, if we do have a separate data layer outside of React, there's one other thing that we can do in a really nice way, and that's routing. So there's a new business requirement. Users get really angry when they lose their state of startup value when they close the browser. And we want to fix that. So what do? Well, we should persist it somewhere. And there are many ways to persist it, but right now, what we want to do is that you kind of can bookmark where you are and come back later. So for that, we are going to use the Kia router plugin. And how does this work? We just add one more thing here called action to URL, which is going to look like this. So values is the current state of all the data that we have inside this logic, like the counter message and so on. So, but action to URL means that if we have the increment action, we want the URL to look like, and we want the same for the increment action. So let's reload, increment, we can, counter, thank you. Clearly see that the URL changes, which is interesting, and we can go back, but then nothing really happens, and that's because we're missing one other thing called URL to action. And here, what do? We do if counter and we have this count here. And actually, we're going to have to add one more thing here called set counter. On pipe and looking at a different screen. So this count, yeah, here it currently says any, but I'm gonna have a new version of key out really soon, which contains a fix that actually makes this a string, which is what it is. So temporary. I'll do like that, and voila. See, the URL is here. I'm gonna reload, and we're still here. And so that's something awesome, I think. Like I haven't seen any other framework that provides you with routing that easily. And since we are doing data first, it really makes sense to do all root resolution and whatnot inside your data layer. If you do routing inside React, it's kind of in the wrong place, I would say, because then it's just a matter of things going back and forward all the time. Like you have all your data in Kia, but then it renders something, then React takes the root, then it calls an action into Kia to change the scene or whatnot. Then that comes back, etc. So keeping everything inside your data layer just makes for a better time. There. I'm going to show you one more thing before we go to questions, which is one more feature of Kia called loaders. And this is again done by a plugin. So yeah, Kia supports plugins. So whatever you have here, you can just write your own. This is all a plugin onto Kia. Listeners used to be a plugin until I put it into core. And actually, all these things in the core of Kia are also implemented as plugins. So it's a very extendable system. There are all sorts of interesting plugins, like you can have, it's not installed, so it's not going to work, but window values, for example, which you would just say, and you would have a value called height that automatically updates on every scroll or resize event and gives you the height of the window. And this height, you could then add here. Or whatever combination. But so it's just a regular value that you can select to make derived properties from, get, etc. Even though the type checking says it will work, it won't because this is not installed, so I'm going to delete it. But that's another cool thing when you can do when you just, again, think of data first. So loaders are a way to interact with your APIs. You would use a loader anytime you need something that needs to load something from somewhere. So this is Kia Router. It's a plugin to help you when your input comes from the URL. But the loader is a plugin that helps you when your input comes from a different API. And so we're going to have a loader called random values. And it's going to default to an empty string. Yes, you can use a loader for async actions, definitely. You would normally use a listener. A loader is like a listener, but with superpowers, and I will get to it in just 1 second. So random values. So the default is going to be a empty array of numbers, and we're going to just have an action called fetch random values. Async. It's not going to take any parameters here, and I'm just going to be lazy and copy the code because who wants to see some guy write down a fetch statement? And there we go. That's kind of all that we have. Let's add the random values here. It's not really going to show much, but again, since I don't want to take too much time, I'm just going to copy this. And random values and random values loading. So a loader automatically creates two values for you. And one of them is called random values. This is what we defined here. And it automatically creates an action called fetch random values, which you can here. And it automatically also creates two other actions, fetch random values failure and success, which you could use, for example, that if your API returns something, you could have a listener to the success action, and you would get the data that was returned from the API. And you could do some kind of side effects with that. But you can also do all of side effects inside the loader, but the main thing in the loader is to fetch data and just return it. It will store it in this thing. And then if you ever need to, you could have like and we're doing data first, so it's all super easy. And we would have another one. So mainly you use this is that you fetch data from the API, and then you use a selector to like sort the returned information or normalize it to a different form and so on. But we just always just store the source of truth, the random values, or whatever API endpoint you get, like your users, startup values, whatever. And then you would use selectors to derive new data from this existing data, and you could combine it with something else. So, but what we're gonna do here, we're gonna just show this. If we reload, something is missing. Can't find set pointer. Okay. So, but can everyone still see me? Apologies there, I clicked reload on the wrong tab and I reloaded the streaming. So, all right. So, but we are not getting the random values. So what would you do to actually get the random values? We need to call this action, and that will initiate all of this, and nothing is really calling it. If we would just do the old school React stuff, we would do an useEffect. Put this here. And this should work. Have all the, and you can see it quickly shows loading there. And we can like really increase our startup's value. But since we're not doing this, I'm gonna get rid of this. So I mean, the problem with this approach, it works, but what happens here is that the logic mounts, then we render the component. Once the component is rendered, only then we start fetching the random values. But we would actually like to do this sooner. So for that, there's just one last thing I'm going to show. It's called events. After mount. Actions again. And now, when our application loads, we got all those random values here. And we can really increase our startup value. So, yeah, that's it. That's kind of what I had for this part. We covered a bunch of different things in Kia, including actions, reducers, selectors, listeners, the router, and loaders. There are a few more things that you can definitely see if you check out the Kia website, but that's everything I had prepared for all of you. So I think we have like 10 or max 15 minutes for questions now. So yeah, thank you for sticking with me. Thank you for listening. I hope this was at least interesting or exciting. I hope, if nothing else, this made you think about designing your applications in a way where you start with the data. And once you just get all your data set up, everything else flows really easily. I mean, yeah, I would, of course, be happy if you use Kia as your data layer, but you can obviously do something else. But this really makes your front-end code really simple. And like I said, Kia scales with your application. So even if we like increase the number of actions here by 5 times or whatnot, you will still be able to just come in here, see increment, decrement, counter. Okay, what's a counter? Gonna go in here. Counter is a reducer. The only way this counter changes is by looking at these values, these actions. And that's it. There's no other way the counter can change. You're not gonna get weird stuff coming in from the sideline and so on. And this makes for really scalable and predictable code. And we're using it in PostHog, where I work now. Please also check out PostHog. It's a wonderful way to do analytics. It's open source. And yeah, we're loving it there. Yeah, so questions. Put this bird back. Can you give an example when you don't start with the data and how Kia fixes that? Well, I can give you a bunch of examples from my work where I just go in there and I see a component that's full of different set state, useState, useEffect, etc. code. And after a while, it's just all going to be a mess for various reasons. You're either going to want the same data from different components, or I'll actually show this as well. Let's make another logic quickly called other logic. And so the thing with Kia, what you can do is that we had selectors. And I'm going to make a selector called triple count. And I'm just going to do counter logic dot selectors dot counter. And then here I'm going to also break. And so this is how you connect different logics together. And with this, you can make some really interesting applications. Like you can have your user logic that stores all your user data, like data for the user who just logged in. Then you can just use this logic in various different places and just pull in data from a component or inside a different logic and so on. So that kind of makes it interesting. I don't know if I really answered your question about when you don't start with data. Is it like putting the state logic in all in one place, a const? Not sure how to answer this. I mean, the logic is definitely not constant. It's evolving all the time. But yeah, I mean, the point is that just keep your components really pure, that it only just uses all the actions and values from a logic. And then you come in here and you can pretty clearly see what's happening. And again, you can just go back and trace the data, like where any of this comes from. So any other questions? I'm still trying to understand about the const question. Yeah, maybe I'll just say that this type gen is also a very interesting part of Kia. As you can see, we now have a logic of about 70 lines. It's all still relatively understandable. And the type here is from here. And why do we need the type gen is because TypeScript does not really support a system where you have one object, this one here, that contains a bunch of actions, but then some other part of this object is already depending on the actions here, and so on. That doesn't really work with TypeScript natively. And the other thing that does not work with TypeScript natively is this kind of stuff. We just want to like pull in types from a different logic, and then we can clearly see it's a number here. So yeah. Is it easy to introduce in an existing app with the type-gen stuff? Yeah. If your existing app is using Redux, then Kia just like fits right in, because you can use all these Redux dev tools to see everything. Type-gen will only interfere if you're using Kia calls. It will not do anything with anything else. So if you're using an existing app with other stuff, then it should not interfere at all. Can we create different logics for different parts of an application and import them where needed? Yes, that's exactly the point. That's exactly how it should work. That you just silo all your data in different logics, and yeah, in your component you just import whatever you need. In other logics you also just import what you need. And I will also just say this interesting thing that a lot of other state management libraries seem to rely on some globals. And that means that you have code like const, or let's put here, const brava equals useState. Then you have to do state dot counter dot something, state dot homepage dot counter, for example. You don't do this with Kia. This for me is dangerous. You're just kind of you kind of need to know this everywhere. In Kia, you just import a full logic. You just get the stuff from the logic. You don't have to worry with magic linking like this. The other thing with Kia is that you saw here that I had this event after mount. So let's add before unmount and just not really gonna wonder how to show it. Yeah, let's just do let's take counter logic. So when the counter is less than 10, we will show the counter. And what this does, and it's 900 something, so 0 here, increase. Okay, it didn't unmount right now. Yeah, sorry. This is using the counter logic, and this is using the counter logic, but I'm just gonna do something you're not supposed to do, simply because I don't want to really like touch any counters here to just prove a point. So if I click hide, this logic is now unmounting. That means that, or if you look in Redux, you only have the router here, you don't have anything else. Initially, the router and then one of the logics, but you just hide it and it just disappears. That means it's just no longer there. That means if you have an application where you have a lot of scenes, like PostHog, my work, where you have different pages here, and all of these are using different logics. And when I click in, so this is insights. When I click into persons, the insights logic just vanished. It's no longer there. You don't have to worry about it fetching values or doing anything with any data. And that's one of the cool things, because it's not only just a logic where you store your state, but it's actually the system to manage the entire life cycle of your state, including different scenes and whatnot. So like if you open a drawer or you open a person here, then all of this is just, I mean, it's a single page application, but the logic just consistently changes depending on which React component is reacting what from which Kia logic. So that's all right. So more questions. Are the values from use values immutable? What happens if you mutate a counter? Yes, everything should be immutable in Kia. You can make a plugin with Immer if you really want to, but everything in Reducer, for example, if you muted it, it's gonna have side effects. So the way we actually, I have one last cool thing about Kia is because it's using Redux, it has this nice feature that this component only updates when any of these values change. Or if something triggers your app to update, then obviously, or if something triggers the root component to update. But if only a part of your page changes, like the text field in a form, only that specific React element will get re-rendered, not everything else, which is the case if you use React context, for example. So that's another cool thing. But yeah, we are based on Redux, so yeah, this should be all mutable. And that means that if you have an object, you kind of destructure it and add a new property and return that, etc. And yeah, if you really want to, you can wrap it with Immer if you want mutable. But I personally believe that it's in everyone's benefit to learn a bit of functional programming. It will just help you write better code. And so that's why I decided not to put Immer or anything like that by default into the framework. So we're out of time. So thank you, everyone. And let's see that there's one last question. I'm a beginner starting with Angular. Are there the same impediments which would justify the same kind of tool? I honestly don't know that. I haven't used Angular in years, and I would suggest using React anyway, but that's just the personal preference. Angular provides you with a full set of everything to manage your application. React just gives you the template layer. And that's the point with React. It is just a template layer, in my opinion. The state management should be done elsewhere. But Angular gives you this entire hand-holding experience. So I'm not sure how Kia fits into Angular. Yeah. So thank you everyone for joining us today. And yeah, please share any feedback that you have about this presentation or about this series of lectures in general. There's a link in the chat. And yeah, I hope you had fun, learned something, and if nothing else, at least you got a chance to see some cool parts for a while, and that's gotta be worth something. Thanks everyone. I'm gonna stop now, so enjoy your day. Bye-bye.